Hi everybody. This is a review of MEOW 10 to help you as you are studying. To review rational and irrational numbers, scientific notation, exponents, squares, and cubes. Be sure to take notes and take your time. Pause the video if you need to help you try a problem and or to reflect about the problem. All right, try it again. All right, so let's scroll all the way down to the first problem. Number 1. It says, which of the following numbers below is irrational? All right, so irrational means that it goes on and it doesn't repeat. All right, so if I take the square root of 169, I can plug that into my calculator. Square root of 169. If you don't know that by heart, that is 13. That's a perfect square, so that makes it rational. The square root of 4, that's a perfect square, so the root is a whole number, 2, so it's rational. The root of 169 is 13. That's a whole number, rational. For C, the square root of 16, the root is 4, because 4 times 4 makes 16. That's rational. The square root of 3. 3 is not a perfect square. If I put the square root of 3 in a calculator, I get something like 1.73, and it keeps going with all these crazy numbers. That means it is irrational, so D is our answer. In order for it to be rational, you should be able to make it into a fraction. It could be a whole number, positive, negative, a terminating decimal, a repeating decimal. That's what makes it rational. Okay, anything that could be made into a fraction. Let's look at number 2 now. Between which two whole numbers does the square root of 5 lie on the number line? Okay, well, if I have my calculator, I can say that the square root is of 5. The square root of 5 is approximately 2.24 if I were rounding it. And it goes on and on and on because it's irrational. 5 is not a perfect square. Okay, perfect squares would be like 4, 9, 16, 25, 36, 49. That's 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, and so on. Okay, so the square root of 5 is not a perfect square. It's going to make a string of numbers that has no pattern. So let's see. The square root of 5 is 2.24, and that is actually between 2 and 3. Okay, that's what it is, between 2 and 3. And if you look at it, let me change the color. If you look at it, the square root of 2, the square root of 3, the square root of 4, the square root of 5, the square root of 6, yada yada, the square root of 9. Okay, we know that the square root of 4 is 2, the square root of 9 is 3. Look where the square root of 5 is. Okay, it's in between the square root of 4 and the square root of 9. So it makes sense that it's between 2 and 3. Those are the whole numbers the square root of 5 is between. Number 3, complete the following statement. The number 6.25 belongs to R, Q, Z, W, and N, R and Q, R and N, or Q and Z. Well, in order to understand this, you need to know what those letters stand for. Okay, so N stands for natural numbers. W stands for whole numbers. R stands for real numbers. Z stands for integers. Okay, well, integers are more like whole positive and negative numbers. So if we look at this, anything that has a z, it's not an integer because it's like a whole number that's positive or negative. So here's a z, so it can't be a. Here's a z, so it can't be d. So the process of elimination, now I have b and c. Now I want to look at whole numbers. Well, because it's on the list, but that's not even one of the options. It's real or, oh, I forgot Q. Q stands for rational numbers. Okay, there's no W in what's left, so I know I can just cross off whole numbers, and with that I can cross off the integers. So I'm left with natural numbers, real numbers, rational. Well, natural numbers are like whole counting numbers, like 0, 1, 2, 3, 4, and it's in this list right there and right there, so I know it can't be C. Okay, rational number, that's any number. That's this one right here is a terminating decimal, so it's rational. It's not irrational. If it was like 6.25, 1, 2, 3, 4, and it kept going, no pattern, then that would make it irrational. But here it's rational, so we know Q is involved for sure because it's rational. And then real numbers. Real numbers is all the numbers included in a number system, pretty much. So B is our answer. So knowing those abbreviations could really help us. 4. It says write the following numbers from least to greatest. So the very first thing you should do is first find the exact value of each of the numbers given to you. Okay, and it looks like that all the numbers that are in A are also in B and C and D. That's not always the case, so you may have to do each of them individually. In this case, it is the case. You just got to figure out what's the correct order. So the first thing to do is find the exact value. So that means plug it into the calculator if needed. The square root of 2 is approximately 1.4, we'll say. Pi, we know, is approximately 3.14. 3 and 7/8, well, I know it's 3 point something, so let me do 7 divided by 8 in the calculator, and I get 0.875. So 3 and 7/8 is the same thing as 3.875. And then 32 divided by 8 is 4. Okay, so right now I have all my exact values. But I still haven't answered the question. This is just how I can organize my work to help me answer the problem. So I want to do it from least to greatest. So the smallest number up here is the 1.4, approximately 1.4. And then the next number is approximately 3.14. Oh, that's interesting. Look, it's going exactly in order. 3.875 and then 4. So that's the actual order. So what we would do is we would put it in order and then we would put it back in the original value. In the original format is how we set it in class, actually. So then the final answer would be square root 2 pi 3 and 7/8 32/8, and that would be our final answer, and there we go. Okay, so again, if each option didn't have the same exact number of values, like each one has pi, each one has square root 2, each one has 3 and 7/8, each option has 32/8. If they were different, then I would do the same process for each one to see which one was in the correct order. Number 5. The population of California is approximately 3.7 times 10 to the 7 people. The land area of California is approximately 1.6 times 10 to the 5th square miles. Divide the population by the area to find the best estimate of the number of people per square miles in California. This is estimating quantities. Okay, so in order to do this, we are going to do 3.7 times 10 to the 7 over 1.6 times 10 to the 5th. Okay, and when I do that, I'm going to treat each one separately. So first I'm going to do 3.7 divided by 1.6 on my calculator. So go ahead and do that and see what you get. 3.7 divided by 1.6. That is going to get us 2.3125. Okay. And I'm going to times, because it says times, this. Well, if I have 10 to the 7th power divided by 10 to the 5th power, they're the same base of 10. So keep the base and write equals. Keep the base, and then we got to subtract the exponents. So 7 minus 5 equals 2. So I get times 10 to the 2nd power. So right now, here's my answer. But that does not look like any of the options. That doesn't look like 24, the way that it's written. It doesn't look like 240, the way that it's written. It does not look like 2,400, the way that it's written. And it does not look like 24,000, the way it is written. But we know that if we're timesing something by the power of 10, we just move the decimal the exponent number of times. So if my decimal is here, 2.3125, I'm going to move it 2 times to the right, because that's the same thing as multiplying by 100. 10 squared equals 100. Okay, so even if you were to put that in the calculator and do 2.3125 times 100, you would end up getting something like this. And this one is pretty close to something here, to one of the options, because it says divide the population, which is what we did, by the area to find the best estimate of the number of people per square miles in California. So the best estimate is B, 240 people, because we got 231.25 as our value. Okay, and these are estimates. Number 6. Number 6 is also similar to estimating quantities in the way that we taught it, in the area that we taught it. So it says simplify 2 times 10 to the negative 3rd times 3 times 10 to the 5th and express the result in scientific notation. So that kind of implies that our answer may not be in scientific notation. So in the end, we're going to have to put it back into scientific notation. Okay, so the best way to do this is to do them separately like this. Let me write it out. Pause this if you need to write it out before I go on. What we are going to do is we are first going to multiply the coefficients. So 2 times 3, that's 6, times 10 to the negative 3rd times 10 to the 5th. Well, I know that if I'm multiplying these and they have the same base, I keep the base and I can add the exponents. So negative 3 plus 5. How much is that? That makes 2. So then that means I have 6 times 10 squared. And this is actually in scientific notation. So even though it implied that it needs to be in scientific notation, it already is in scientific notation. I didn't have to do anything special. That was pretty nice. Okay. There may be another question where I have to put it in scientific notation, so it's good for you to know how to do that. All right, number 7. Change this big number from standard form to scientific notation by filling in the boxes. Well, I know for scientific notation, if I don't see the decimal, it's always at the end. And where I need it to be is right here, so that there's only one digit to the left of that decimal. Okay, so I know that this chunk right here is what I'm going to be writing in this box, 2.347. Okay, I don't include all these extra zeros. That's what's nice about using scientific notation is to the power of 10. I don't have to include those zeros because I'm going to simplify it by putting this big number into scientific notation with the power of 10. Okay, this exponent depends on how many jumps it takes from here all the way to there. So let's go ahead and make those jumps. If you don't see the decimal, it's always at the end. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that should be to the 9th power. And remember, if the exponent is positive, then it's a big number. If the exponent is negative, then you're going to end up with like a decimal like this or something like that. Okay. And that's going to help us with this one. Look, this is a small number, so I know automatically that it's going to be a negative exponent. Now here's a decimal. I want it to be right there so that there's only one digit to the left, and that would make 6.78. Okay, but let's count the jumps. 1, 2, 3, 4, 5. So to the negative 5th power. So 6.78 times 10 to the negative 5th power is our answer. Make sure you show your jumps. Let's look at number 9. Well, this is an exponent raised to another exponent. So I'm going to multiply these. So x to the negative 2 times negative 7. So negative times a negative is a positive. 2 times 7 is 14. That matches this one right there. If I had x to the negative 2nd to the 7th like that, that would be x to the negative 14th. And because there's a negative in the exponent, I would have to flip it, and then our answer would be D. But it was not negative, it was positive, so just x to the 14th. All right, number 10. Which of the following show the proper laws of exponents? Note, more than one option may be correct. Select all the correct answers. All right, so for this one, it's timesing and it has the same base, so I can add the exponent. So it should be 3 to the 5, 6, 7, 8th power. This one says to the 10th. Nope, that's incorrect. B, all right, I'm raising a power to a power, keep the base, and then multiply the exponents. 2 times 3 is 6. Ooh, that's correct. There may be more than one answer though. So let's look at C. Oh, I'm dividing exponents that have the same base. So it's going to be 8 to the 5 minus 1 is 4. Oh, that one's correct. Now let's look at this one. I'm multiplying with the same base. So 7 to the, I'm going to add the exponents. 4 plus 4 is 8. Oh, that one is also correct. So we have 3 correct answers for that one. So remember, if you are multiplying with the same base, you add the exponents. So that's a 4. So it should be 5 to the 9th. If I am dividing and they're the same base, then I can subtract these exponents and get that. Oh, I'm sorry. Over here I put 5. That should say 3. Okay, they're the same base, so keep the same base. The only thing that gets really tricky is when you have exponents that are negative, and you may have to deal with integers, which is fine. And remember, if you get a negative in the exponent, you're going to have to flip it. Okay, so if I have 4 to the 2nd times negative 3, I'll show you what happens when we have to flip it. This will be 4, and then I multiply these ones when it's a power raised to another power, and I get negative 6. But there's a negative in the exponent, so I'm gonna have to flip it to make it positive. Okay. All right. These ones were extra credit. Okay, so I had to do more about the rules for number 1. It says select the ones that properly applied the different laws of exponents, making sure to keep positive exponents. Note, more than one option may be correct. Select all the correct answers. So it's very similar to the number 10, right? But it's just different numbers basically. So if I look at this one, it says 4a to the third squared. There's more than two things in here. This is the same thing as saying 4 squared times a to the third squared. So that's the same thing as saying 16 from 4 squared times a to the 6th power. So that one is true. If I look at this one, 2 times x to the 4th squared, I gotta distribute that exponent basically. So it's 2 squared times x to the 4th raised to the 2nd power, because I'm putting that exponent of 2 to everything that's in the inside. Okay, so then I get 4 from 2 squared is 4. And then I get 4 times 2, which is 8. So times x to the 8th power. Uh-oh, this one says 6. So that one is not the answer. If you added those exponents and did 4 plus 2, you would have got 6 and would have thought maybe that B was an answer. So make sure you are very good with these exponent rules. Okay, you got to be very good with them in order to answer these properly. I'm going to change the color to make it easier for us. All right, now this one, I have x squared times y to the negative 1st raised to the 2nd power. So that's the same thing as saying x squared times y to the negative 1st squared. This is the same thing as x to the 4th times y to the negative 2, because negative 1 times 2 is negative 2. But there's a negative right here in the exponent, so I'm going to have to flip it. So our final answer should be x to the 4th over y squared. And that does match right there. That one is an answer. Let's look at this one. 2a to the negative 2nd cubed. Let's see. That's the same thing as saying 2 cubed times a to the negative 2nd cubed. So that's the same thing as 8 times a to the negative 6, because negative 2 times 3 is negative 6. And that's the same thing as 8 times, oh, that's going to have to flip to the bottom because it's a negative exponent. Nope, that's not the same. So right now we only have A and C as an answer. Please practice this problem again. Stop this video right now and try each of these again until you get them right. That's part of practicing, right? That's studying. All right, I have all the work right here. See if you can get the same answer. So pause the video right now and take 4 minutes to do that, 5 minutes, 10 minutes, whatever you need until you can get those answers. When you are done, press play and then I'll continue. All right, so hopefully you took my advice to try to do that. All right, because that would help you a lot. You need to know those exponent rules and when to flip. All right, number 2, it says, is negative 5 squared equal to negative 5 squared, like that? Okay, this one's an interesting question because this actually should have been asked a little differently. It should have been, is negative 5 squared equal to negative 5 squared, like this? Okay, because those are two different answers, and that's how this was meant to be written. All right, so if you got this correct, I gave you the credit for it, even though I think your understanding of it might have been wrong because of the way that I wrote it, where I put that parenthesis. But it didn't count against you since it was extra credit. If this was an actual test question and not extra credit, I would have deleted this question. Okay, so if I'm looking at this one, this is saying that -5 is squared. So that means it's -5 2 times because the squared is over the entire -5. So that would make +25. But this one, the -2 is just attached to the 5. So it's like a negative's on the outside, and then we're doing 5 times 5. So 5 times 5 in the inside makes 25, but I have a negative on the outside, so the answer to that one is -25, while this one is +25. So they're different answers. Okay, so the answer should have been D. But again, this was weirdly written. It should have been written like this one and this one. Okay, that's how it should have been written. The parentheses shouldn't have been here. The parentheses should have been there. Okay, but again, it was extra credit, so it didn't count against you. But if you got it right, then I gave you the points. All right, our last one. I'm going to make it green. Okay, fill in the boxes to make this statement true. So the cube root of 8 equals blah, since blah times blah times blah equals 8. So the answer should have been 2, since 2 times 2 times 2 equals 8. So that should have been the answer. Okay, we had questions like that. So my advice to you is to make sure that even though you did your studying right now with this, to try to retake it if needed. I suggest you trying this again on a separate piece of paper on your own so that you are ready to retake this test. Review the previous study guides, the classworks, your homework to help you so that you are really prepared to study. Okay, try to do these problems again on your own. That's what's going to help you a lot. Okay. Your calculator is very useful. Make sure you know how to use it. Scientific notation, there has to be one coefficient in the front of the decimal each time. All right, if it's a small number, it's going to have a negative exponent. If it's a big number, it's going to have a positive exponent. Okay. All right, good luck.